like to welcome co-founder and CTO of HashiCorp, Armon Dadgar.
Thanks so much, Eric. Awesome. Cool. Thank you so much, Eric, and thank you all for being here. I want to give a very warm welcome to all of you. Thank you so much for coming out to HashiConf US 2019 in Seattle. This is sort of personally very exciting for me. Seattle's actually my hometown. Grew up not far from here. And in many ways, it's sort of the spiritual origin of HashiCorp itself. So I'm not sure that that many people actually know the origin story of HashiCorp, but it really actually started, in some sense, at the University of Washington, just sort of a few miles off from here. Both me and Mitchell enrolled at the University of Washington in 2007, and I think it was sort of obvious to both of us coming in that we loved infrastructure, we loved sort of computer science as sort of a whole. It was sort of a passion even before we got there. And it was through, in some sense, a bit of happenstance that we ever met. It's a fairly large school, but I think both of us were sort of drawn to a lot of the same sort of topics in terms of, not only how do you write the software, I think we were both interested in that, but in some sense, we both came to it from a bit of a system administration background. So we were interested in how do you actually manage this stuff? How do you deploy it? How do you actually think about sort of the system administration side of software, not just the authoring? And so we both happened to end up on the same research project, called the Seattle Project aptly, but good luck ever Googling for that. And it was on this project that we were sort of working on the same component and really got to meet each other and find out that, wow, we really do share a bunch of interests in terms of what now is sort of HashiCorp. In the meantime, we formed sort of a bit of a startup working group and worked on a number of different ideas, everything from sort of a digital pet store to a point of sale to a, how do you buy textbooks online for college students. And so there was a long list of failures before we ever got to HashiCorp. So, it's personally very exciting, I think, for both me and Mitchell to be here. I'm very thankful that you're all able to join us. For those who've maybe not been to HashiCorp before, or for those of you who've been to a HashiConf before, you might notice that this one's a bit larger than they've been in the past. Today we have a little bit over 1,600 people joining us. That's probably a good 500 people more than we had last year. And it's from 570 different organizations. We have 360 different cities, 28 countries, and 6 continents represented here. So we're going to work on that last continent for next year. And so today we are, not just today and tomorrow, we have an amazing set of lineup of talks for you. We have 4 different tracks. We have over 24 different talk sessions for you. There's an amazing set of speakers representing an awesome set of companies. So I encourage you, go to as many of these sessions as you can, learn about the best practices, get their shared experiences, talk to the speakers afterwards. I know there's a lot kind of going on here, especially with 4 tracks, so all the talks will be recorded. So if you can't make up your mind between which talk you want to go to at any given time, pick one. Don't worry, we're going to record and share the rest after the conference, so you won't miss out. One of our goals with events like this is to make them as diverse and inclusive as possible. We want to get a broad range of people who bring different backgrounds, different perspectives, different experiences. And there's a set of underrepresented folks who can't get here, sometimes because of financial sponsorship, sometimes just because their corporate group won't pay for their trips. And so one of the things we've focused on is the HashiCorp Diversity Scholarship to bring folks who are sort of traditionally underrepresented at events like this and bring them out here. So among the group, you're going to have people from all around the world who are joining us for this. Please use this as an opportunity to meet new people and break out of the folks you maybe talked to last year. What's exciting for us is when we talk about sort of the global HashiCorp community, it's been sort of crazy to watch the community grow, particularly from the lens of the HashiCorp user groups. This is an initiative we launched only a few years ago with 1 or 2 groups. And just this week, we crossed the sort of 25,000 user mark within the HashiCorp user groups. So that represents something like 110 different groups from 44 different countries around the world. If you haven't joined one in your local neighborhood, I encourage you to seek it out and do so. If there isn't one and you want help starting it, please reach out to us and we're happy to help you get that going. One of our goals when we talk about sort of HashiCorp, HashiConf, and in general the sort of broader community is how do we bring everybody together to do this sort of knowledge sharing and discovery, right? I think for many of us, these are relatively new topics. We're just getting into whether it's infrastructure as code or security or service networking. And so it's important for us to be able to sort of learn from each other, right? Just as much as it is from events like this. And so the challenge is, while we can get a few thousand people at our different events, that's only a small fraction of the whole community. So one of the things we launched over this last year was the community portal and the community forum. And our goal was to take the sort of splintered conversation that we had on Twitter and Reddit and Stack Overflow and our mailing list and sort of all over the place, and bring it into one place that's searchable and indexed, and bring the HashiCorp employee community there as well. So on the forum, you'll actually engage not only with your fellow community members, but also developer advocates and engineering teams and product community within HashiCorp. So if you haven't seen this yet, you can get to the community portal at just community.hashicorp.com and sign up and start participating. So with the growth of the user community itself, we've been sort of struggling on our side in some sense to keep up with that growth. Last year, we were a little over 320 people. This year, we've expanded that to a little over 600 employees around the world. And this has allowed us to ship new features, fix more bugs, improve the documentation, add a ton of learning and educational content, and support many more customers. Right? So it's very exciting for us. You'll see a lot of new HashiCorp faces around the conference as well. Talk to them. They'll be at the HashiCorp Zone and Cafe and booths around the event. And all of this is really made possible by a growing set of our customers. Our tools started out in some sense as an attempt to scratch our own itch a little over 6 years ago. And today, the open source tools are used from everyone from individuals working in their garage on a new startup idea all the way to the largest Fortune 10 companies. And when you look at some of the commercial customers, they span that same range. Some of the world's largest and most recognizable companies are now customers and use our tools to power their mission-critical workloads. So we're very excited and proud to be a part of that and work hard to ensure your success as well. So when we talk about what's driving this growth in both the HashiCorp user community as well as our customer base, it really goes to this sort of thesis we have that the world is going multi-everything, right? And when I say multi-everything, the thing that probably comes to mind is multi-cloud. And that's, of course, sort of an important component of this, right? When we talk about multi-cloud, there is this sort of massive transition taking place where we're moving from traditional on-premise data centers into the public cloud, right? And it might have been sort of a single cloud a few years ago, but what we're now seeing is there's sort of multiple sort of major public clouds. And in general, we're seeing the world's largest companies adopt a multi-cloud strategy, right? It's not one of the above, it's sort of all of the above. But at the same time, it's not just a transition of where our things are running, it's what are we running, right? So we're also going multi-platform at the same time. If we looked at infrastructure 5-10 years ago, it was largely fairly homogeneous. It was virtual machines, it was physical machines. That was sort of the abstraction we thought about, right? What's happened increasingly over the last few years is we've gone multi-platform as well, right? Now we think about containers as part of our mix, right? Increasingly, we're starting to think about serverless capabilities, whether that's function as a service, whether that's container as a service, whether that's higher level APIs sort of provided on demand. But it's no longer that we think about our infrastructure simply as a collection of VMs, right? There's more interesting technology that's part of that mix, right? So how does this change how we think about our approach? And I think the last major shift is at an application architecture level, right? Not only is where we're running and what we're running, but the types of applications, the style of application is changing as well as we embrace microservices and service-oriented architectures, right? So we're moving away from the large monolithic service, and we're decomposing that into many smaller services. Some of this is so we can get better code reuse, right? So we're not re-implementing the authentication or user service between our mobile API, our mobile front end, desktop front end, API front ends, right? So we can reuse logic between these different tiers. But part of it so that we get greater agility, right? Different teams can work on different components. They can run independent of one another. And so we can parallelize the work that's taking place by splitting it out of the monolith, right? So all of these are kind of components of this kind of going multi story. And so our view is this sort of has a few different fundamental impacts to how we think about managing infrastructure, right? At the base layer is how do we think about provisioning, right? We're moving from a world where our assumption was dedicated fleets of machines that were relatively homogeneous to on-demand capacity that's very heterogeneous, right? It's going to be a mix of VM and container and serverless and functions, and all of that is going to be on demand. When we think about the security layer, we're moving from a sort of perimeter-oriented, IP-based security model where we said we're going to lock the front door, use firewall rules, think in terms of IPs, to a world where we say, you know what, the IP is dynamic. We don't really know what it is. It's running in Kubernetes, right? My network is low trust because I have too many front doors. I'm operating in 5 different cloud environments, right? So we have to rethink our approach and think more about identity, right? What is the web service trying to do? Who should be allowed to access the database and not think about IPs? When you think about networking, we're also shifting away from the notion of a host, right? It used to be that this machine is a web server, this machine is an API server or a database, right? Where now we think about services. I don't really care what's running on that machine. I have hundreds of machines as part of my Nomad cluster. I don't really know what's running where, right? What I care about is routing to the user service or the billing service, right? And some of these services might not even exist until they get invoked, right? If I'm running on a Lambda endpoint, there is no host. Until the invocation happens, I don't even know an IP, right? So it's a different way of thinking around how do I route to a service as opposed to how do I route to a host. And then the final layer is at the runtime. We're moving away from dedicated fleets, these 50 machines are a web server, these 10 are a database, to these much larger dynamic fleets that we're scheduling over, right? So there's a bunch of changes in terms of the core assumptions of how we manage and run our infrastructure, right? What this translates to in the landscape then is a ton of fragmentation, right? You see a lot of different tools trying to solve each of these different pieces. There's a mix of open source and cloud native, and it's sort of hard to kind of see the forest in some sense for the trees here. And so our goal when we talk at HashiCorp is really how do we provide a consistent way of operating across all of that, right? We want a set of tools that are easy to use, that solve a specific problem, but that allow you to work across any of the environments you might be in. So it's great to talk about sort of the grand picture, how these pieces sort of fit together. But at the end of the day, that's not really how we think. That's not how we really solve problems on a day-to-day basis, right? Where it really starts, it's with practitioners. It's folks like you who are trying to solve a specific problem. How do I provision something in Amazon? How do I secure a database credential, right? So we're trying to solve these specific problems, and our design ethos at HashiCorp has always been pretty simple. It's build tools that we would want to use for these problems, right? In some sense, we started by building for ourselves and went from there. And so we strive to really make sure that simplicity is at the forefront of what we do, usability, and keeping the tools scoped to solving very specific problems, right? If we succeed at that, we create a new set of problems, right? Inevitably, if you get good at Terraform and you're happy with it and it's working well for you, you try and figure out, well, now how do I do this with my team members? How do I collaborate with other people? And this actually creates a new problem, right? Collaboration is actually a different problem than the one you had when you started as an individual. So now this is something else we need to solve for. And if that goes well, right, and you scale it even larger to teams of teams or your organization, then you have an even different set of challenges, which is great. How do I do this now in a way that meets our governance and regulatory sort of standards and challenges as well, right? So each of these is a great problem to have, right? But they're different ultimately. And so when we talk about Terraform, everything sort of started with the practitioner with the open source tool, right? It was really how do we solve that problem of doing multi-cloud provisioning in an infrastructure as code way that's going to be simple and expand to sort of multiple clouds and providers, right? From there, we heard from a lot of our users and customers that they wanted to use Terraform in an enterprise setting, but they had a whole different set of challenges. How do they connect it back to audit logging and single sign-on and policy-based management and role-based access controls? There's a ton of sort of scaffolding needed around the open source tool to make that work in an enterprise setting. And then for folks in the middle, this left a major gap, right? How do you collaborate with your peers if you're not in a regulated corporate setting? Maybe you don't need Terraform Enterprise. It's too big. And so I think what we announced last year was Terraform Cloud along with the free tier to start to solve this problem, right? Much like GitHub provides a shared notion of sort of a master branch for a development team, what Terraform Cloud does is provide a shared set of state so that you have a master notion of what your infrastructure looks like, right? It becomes a point of collaboration just like GitHub does for development. And so last year we announced this Terraform Cloud along with its free tier, which provided just that sort of centralized state storage. For folks who have used Terraform, I know in the past you might have used remote state storage and console and S3 buckets and things like that, but we wanted a more first-class experience. So what I'm super excited to announce today is a major expansion to the feature sets and capabilities of the free tier. So there's sort of a few things that I want to touch on here. One is the state storage, which we talked about last year. It's still a part of it. But now we're actually bringing in remote abilities to do plan and applies, right? The full sort of Terraform workflow within Terraform Cloud. So now when you run Terraform plan or apply locally, it'll actually be executing it server side in a centralized way. right? And so what this allows you to do is connect the experience of the command line, where it's unchanged, to now a web interface where you and your peers can see what's actually happening, what's a history of those changes, to an API, which will allow you to do all those same things. So you get the full workflow, but now you can access it in multiple different ways and collaborate with a team as opposed to just on your machine. In addition, the other big problem is how do we start to share and have these repeatable patterns in terms of working together, right? So we'll talk about the private module registry in a second here. So what does this actually look like, right? If we look at the command line of sort of Terraform, if we're running a local plan, it looks exactly the same as before, right? And this is by design. Nothing changes, right? Your local workflow is sort of unaltered, right? When you're using Terraform Cloud, Terraform works just as you would expect, right? In some sense, nothing changes. The command line acts as sort of a terminal to sort of the API behind the scenes, and is invoking the right APIs for you transparently, but the user experience is unmodified. But what happens then is now you can see that exact same run happening in real time in the dashboard. So you and your peers can see it, you can comment on it, you can collaborate on it. There's a history of it that operates sort of like the git commit history, right? You can log in and sort of do the git blame, right? How did this change get made? When did it happen? Who made the change? Why did they do it? What's the git commit that it ties back into? So it gives you this sort of way of understanding how these changes happened in a central view. This is a view if you zoom out then to looking at sort of multiple workspaces, right? What ends up happening often with Terraform is people start with a relatively small configuration and it grows with complexity organically over time until it becomes these giant configurations, right? And these become difficult to manage. They become higher risk when you're making a change. It takes longer for applies to take place because there's so many resources under management. And so one of the things we want to encourage is a more granular decomposition, right? In some sense, there's an analogy to be made to the microservice architecture, which is you don't want one monolithic application. You want many smaller services. Same with Terraform. You don't want one massive configuration. You want many smaller workspaces that you compose together. And each of these then becomes safer to work with, smaller blast radius, easier to reason about, but you can compose them into a large infrastructure, right? So Terraform Cloud gives you this ability to think in terms of these smaller chunks and compose them together easily, right? One of the advantages as we think about shifting into this mode, right, is we don't want to break the local workflow, but how do we get out of the business of distributing, let's say, AWS credentials to all of our developers, right? Instead, we can define those centrally, put them in as a variable to our execution, and those will get filled into Terraform just in time for the execution. But we can mark them as sensitive. We don't have to distribute them to the whole team. If we need to rotate or revoke them, we can do that in a central way, right? And so it puts a central place where we can manage these things rather than having to worry about distributing credentials and settings to everyone in our team. The final kind of component of this is the private module registry, right? So we've had the Terraform public module registry for a few years, and it has thousands of modules that sort of have the best practice ways of getting started with defining networks and middleware and common application architectures. And this is great if you're willing to build a pattern and share it for the whole community. But what if you want to take one of those and modify it in a way that makes sense for your business, your context, right? It might not be appropriate to share that with sort of the whole world. And so this is where the private module registry helps, right? You can build your own modules that are designed for internal distribution, right? So it might be tweaks that only make sense within your environment. You can capture all those, put them and share them internally. And just like the public module registry operates the same way, just with a different set of visibility and controls. And so I'm super excited that all of this is available today, right? You can log in today. If you have an account already, you can log in. It's all there. If you don't yet, visit terraform.io. You can follow the link and register and get started with the free tier. So one of the challenges when we talk about sort of the free team collaboration is over time, you're going to add more users, right? You're going to get to a bigger state where then your problem changes a little bit, right? When it's a few users, you're not as worried about things like security or policy or consistency. It's only a handful of people, right? But as you get bigger, you do worry about, like, should everybody have the ability to modify my core network systems, right? Should everybody be able to change the core, shared databases? Or do we want to have more fine-grained access, right? Maybe app teams can modify their infrastructure, but core networking is handled by someone else. Shared databases are handled by someone else. And we want to be able to share that, but without sort of giving away the keys to the kingdom. And similarly, we might want a consistent enforcement of policy, right? What instance sizes are we allowed to use? What regions are we allowed to deploy? And what times of day can changes be made? And so this is a different set of challenge that we really look at solving with sort of a different tier of Terraform Cloud. And so I'm excited as part of that to talk about Terraform Cloud for Teams. So when we talk about Terraform Cloud for Teams, it sort of adds on top of the free tier and looks at slightly a different set of challenges, right? Which is how do we define a set of teams and provide different sets of permissions to them in terms of who is allowed to make what types of changes in a fine-grained way. And it allows us to collaborate with sort of an unlimited number of people. It also changes the module registry to bring in role-based access control. So you might want some people who are allowed to publish the modules and other people who are only allowed to consume, right? And lastly, it also exposes the Sentinel, our policy as code engine, for doing that sort of fine-grained policy, right? So what this looks like is what you would expect, right? Very similar to something like GitHub. You can define a set of teams and then govern what they're allowed to do. So you might say my core network team, they're allowed to define and modify the network, while everybody else, they can read it. They need to know what's my VPC ID and the subnet IDs and things like that, but they shouldn't be able to modify any of that, right? With the Sentinel engine as well, you can define very fine-grained policy. Things like allowable regions, allowable instance sizes, times of day that you can deploy, et cetera. And you can install these in different modes, right? Whether they're hard mandatory and there's no way to escape them, right? Might be a security thing like don't open the firewall to the whole internet. Or if they're simply advisory, like, hey, this instance type is deprecated, you should probably stop using it, right? We're not going to stop you, but here's a heads up. So this is all part of our sort of Sentinel engine, and this gets exposed as well. And so with this, we sort of round out thinking about these different layers, right? Terraform starts with the individual practitioner, and that's where it grows from, right? You start there and goes into then sort of smaller size teams. And from there, if we succeed, you end up using it at hundreds or thousands of users at the sort of enterprise tier. So now there's kind of multiple ways to get started. With Terraform Cloud free tier, we want it to be super easy to get started. It's free, register today. And at some point in there, you might transition to a larger team where you start with Terraform Cloud for Teams, which is $20 a user a month. And from there, if you get really large, we're happy to chat with you about Terraform Enterprise if you need things like single sign-on, single tenancy, hosting it behind your firewall, and things like that. And so part of our goal here was really thinking about how do we have a consistent Terraform user experience. I think with some of you who have been using it for a few years might have seen that Terraform's user experience sort of changed at every scale. When you started day one, to you had a team and you had to cobble together something in a CI/CD pipeline, to you tried to figure out how do you sort of wrap policy around it at scale. The challenges sort of force you to break your workflow. And so this was really a key thing for us, was really going back to that sort of the Tao of HashiCorp, the notion that workflow is kind of our most important thing. And thinking about how do we make that consistent? How do we not break it, even as you go from 1 user to 1,000 users? And so this is really part of that sort of standardization and making that a really clean, simple journey. So we're excited for you to try it and excited to have your feedback. So when we talk about Terraform, we're often talking about sort of provisioning as a lifecycle, right? And what I mean by that is, it starts with a day one, right? Day one is what most people kind of mean when they talk about provisioning. It's going from nothing to something, right? I want to go from I have nothing running to I want my initial network and VMs and things like that, right? And in many ways, this is sort of the simplest problem, right? There's kind of nothing to mess up. There's no users, there's no data, there's nothing running, right? So the worst you can do is fail to set it up, right? So this is kind of the luxury, easy problem, right? As you get to day two, this is when life gets more challenging, right? You have an existing infrastructure, and now you want to evolve it, right? You're going to scale up, scale down, change a config, et cetera. But now there's users, there's data, there's live production traffic, right? So this is a much more challenging problem because now there's risk, but it's the problem you have every day outside of day one, right? And so this is where we spend a lot of time and attention on things like Terraform Plan to make sure that you have the confidence to understand what's going to happen before it happens, to give you fine-grained ways of making changes and give sort of operator confidence. And then there's ultimately day N, right? You have an existing set of infrastructure, but you don't need it anymore, right? Maybe it's a testing environment, maybe it's a service that you're turning down, but you want to go from something back to nothing, right? And in this sense, you complete the life cycle, right? You went from nothing back to nothing, right? Sort of cradle to grave. And so I think when you think about Terraform in that lens as a life cycle, it becomes clear that it's sort of an ongoing activity. Right? It's not something you do one time, day one, and then you sort of forget about it, right? You're kind of managing it, much like code. It becomes a living, breathing thing, right? And so if you think about it through that lens, provisioning doesn't happen in a vacuum, right? It's connected to other things in our infrastructure. It's connected to the day-to-day of how we work together, right? And so one of the goals is how do we enable Terraform not just to be a day one provisioning tool, to be a platform that's sort of part of your infrastructure and part of your life cycle. So we kind of look at the ecosystem around Terraform. There's the southbound side, in some sense, is probably what people are most familiar with. Right? This is where I'd put the Terraform providers. Right? Whether you have the major cloud providers, whether you have big on-premise vendors like VMware and Nutanix and F5 and Cisco, whether you have sort of PaaS like Kubernetes or SaaS like Datadog and New Relic and GitHub. The providers are what allow Terraform to sort of integrate with this whole universe and manage sort of 250 different sort of types of providers today. Right? So there's always been a concerted effort on how do we grow that ecosystem and really support everything that you might want to manage as code. But then if we talk about the northbound side, it's not about technology and infrastructure, it's about workflow. Right? It's how do I actually go about making these changes? What's the environment in which I'm working? And there the focus is on things like version control systems, right? GitHub and GitLab and Bitbucket. Right? So where am I starting my infrastructure as code journey? Oftentimes in version control. Right? But then you might have a set of CI/CD practices that you build around it. So how do we integrate with Circle and Jenkins and Travis and all of the kind of major CI platforms that you might want to use? And similarly, how do I collaborate? Right? Is that in Slack? Is it in other sort of mediums? Do I have to use things like ServiceNow to do approvals for changes? Right? What are the workflow pieces that I need to really integrate this into how I get things done? Right? And so our goal is really to start focusing on not just the southbound side, but the northbound side, and really create a rich ecosystem around Terraform. And so when we think about Terraform, there's sort of multiple inputs, right? There's things that might want to trigger it. There's things upstream that Terraform might want to notify. And there's systems that might want to interact with it on the southbound, right? So if we think about triggering, one major thing is version control systems, right? I make a change, and I want to automatically trigger a Terraform plan or a Terraform apply from that. And so today we have tight integrations with GitHub and GitLab and Bitbucket and more coming. But what about organizations who maybe aren't ready to go full infrastructure as code? Right? These are organizations who are maybe used to a more ticket-driven sort of approach. They're using an IT service management system. And so how do we meet those people halfway? Right? How do we give them some of the benefits of infrastructure as code without expecting them to fully abandon the way they work today? And so one of the major integrations in the last year that we're super excited about is ServiceNow. Right? So for users of ServiceNow, they might be more comfortable going through a UI and using sort of a point-and-click ticket-driven interface. But now what Terraform Cloud enables you to do is basically automate the fulfillment of it. So you can expose a service catalog of different services, maybe a Java MySQL app, for example, and the user can come in and basically request this, right? But although it sort of looks like requesting a ticket, the back end of the fulfillment is automated, right? So this kicks the job out and uses the Terraform templates to actually do the execution and the sort of provisioning. And so the benefit for these organizations is they eliminate that sort of multi-week wait for infrastructure, but without totally disrupting their workflow. Now, what about the things that Terraform needs to talk to? Right? Provisioning doesn't just end when the infrastructure comes up. There's a bunch of upstream services that we might want to connect with. Right? One of the things that we've heard sort of loud and clear is that you want Terraform where you actually collaborate. Right? So there's now native Slack integration, so you can get notifications anytime a plan gets scheduled or an apply completes or an approval is needed. And so you can collaborate where you're sort of already working. Right? But there's sort of a whole host of upstream services that you might want to talk to. Right? And so this is where having sort of a rich set of webhook comes in, is you can use this to integrate with either other ISV technology partners, custom software you build in-house, simply gluing together different pipelines with CI/CD solutions, but it lets you really bake Terraform into a broader ecosystem of automation, right? And so this is really how we think in terms of how do you enable this to be sort of a piece of a larger puzzle. And so before we move on from Terraform, there's sort of like one more thing in this ecosystem that I want to talk about. When we talk about kind of the initial goal of Terraform, it was how do I enable the provisioning to take place, right? And the focus here was the Terraform open source tool, its infrastructure as code as a philosophy, and it's a pluggable, extensible set of providers, right? From there, it sort of opens up a new set of problems, right? Which is like, how do I manage the risk of this? Great, now I have people who are provisioning infrastructure in the cloud, they're doing whatever they want, right? How do I make sure whatever they want isn't sort of going against what I want, which is I don't want open firewall rules, and I don't want people deleting my core networks, right? And so, this becomes sort of a multifaceted approach. It's things like role-based access controls. It's granular workspaces to reduce risk. It's Sentinel and policy as code to define sort of a sandbox. So it's how do we lower the risk that things that we don't want to have happen. But then this opens up sort of the next challenge, which is great. We've sort of defined a sandbox in which we can do things. We've enabled people to provision. But oops, we provisioned a whole lot of things that we're not using, and we left them running. Or did we really need the quadruple extra large with the TPUs for our dev box, right? So there's a bunch of costs that starts to sort of accumulate that can become sort of shadow, right? And so I'm super excited today to announce cost estimation in Terraform Cloud and Terraform Enterprise. So as a quick sneak peek of what this looks like, cost estimation runs in sort of a workflow step in between the plan and apply phase. So you write your infrastructure as code, you run your Terraform plan and apply just like normal, and in between those two phases, Terraform will analyze what your configuration is and make a best guess of what this is going to cost, right? So it's going to look at the actual resource definitions and understand, okay, what will this cost on an hourly or monthly basis, right? What's the point estimate of this apply? And what's the delta from your existing infrastructure, right? So this starts to give you visibility into, oops, did I really intend to introduce that much cost? But it also lets us annotate these workspaces with those estimates and give you some idea, okay, if I have hundreds of workspaces, where does my cost sit, right? How did I get to this one sum picture that I get at the end of the month in a bill? But where is that cost really originating, right? And so unfortunately, I don't have time to go deeper into this today. I would encourage you all, if you're interested, to check out the keynote by Paul and Robbie later this afternoon. They're going to go much deeper into sort of all the announcements and all the kind of latest and greatest with Terraform. But again, all of this stuff is available today, everything I talked about, right? So the free tier stuff, all the new teams, cost estimation, it's all available. Go to terraform.io, sign up and register today. At this point, I'd like to welcome Mitchell Hashimoto, founder and CTO, to the stage. Thanks so much.
All right, hello everyone. Before I get started, a lot of the people that worked on what Armand just talked about in Terraform, they've been working on all that for a couple of years now. I think it's amazing. If you think it's amazing as well and want to thank them, could you just give them a round of applause right now, please? Thank you, Terraform team. Cool, so it's amazing to see you all here today. I am going to be talking about Consul. I've been really excited about Consul lately. For those of you who have been watching multiple of our events or have been to multiple keynotes, you may notice that either by choice or by luck, I have gotten the Consul section 4 events in a row now. That's not really a mistake. I am really excited about Consul. And why is that? You know, Consul is exciting to me because it is chipping away at solving this very important service networking challenge. Armand explained the challenges of multi-everything, and networking really sits at the core of that. And to show you visually what I mean, when we've been talking about multi-platform, this transition has been going on for a very long time. If you zoom out sort of to 3 or 4 decades, you could begin at mainframes, and if you find any company that's been around long enough, you'll see almost all of these still in action today. The mixed technologies, the multi-platform, multi-paradigm that's going on is still very much active, right? There's mainframe to bare metal to VMs, and then recently containers and serverless. But even though containers or serverless are recent, the notion of paradigm shift and technology change in a company is not new. And when you look at all of these things, they still interoperate today, they still work together today. And the one thing that has always been there as a least common denominator, the one thing that has made applications on different platforms always work, has been the network. No matter how much changes above, we've always been able for the past few decades to rely effectively on TCP to be there for us in order to make everything work. So any protocols that live on top of TCP sort of enable us to connect things like containers to mainframes. And even for newer sort of cloud native or cloud first companies that started with cloud VMs, they've now had to endure the paradigm shift of container platforms and serverless. So sort of much in the same way that when cloud was coming up and those companies got to point and laugh a little bit at the companies stuck with physical data centers, they're now being pointed and laughed at for being stuck with cloud VMs as people move to containers and are realizing the very real business challenge of having mixed technologies and sort of the importance of the network underneath to make this all work together. And so when we look at the network and try to use that as a solution for these mixed technologies, we run into three key challenges. There's the challenge of naming, authorization, and routing. Naming is the most simple challenge. It's the one you run into first, typically. It's really basic. It's just what do you call something in order to address it? When the web service needs to talk to the upstream auth service, how does it tell the network that it wants to talk to that thing? Traditionally, we've sort of used IP addresses, and particularly static IP addresses or virtual IP addresses to make this a reality, to give something a fixed name so that when we say, in this example, .51, we know that we mean to go to the auth service. When you had very static machines, this worked totally fine. As we've sort of scaled out horizontally, and in this example having multiple auth services, you still want some sort of fixed name to make this consistency. And historically, in a traditional static environment, as Armand showed, you would reach back into load balancers for this solution. And these load balancers are doing very little in terms of what they're capable of. The primary thing that they're solving here is the naming challenge. Load balancers don't change very often. Their config does, but the machines don't. So you're able to keep this static address and route it to these more dynamic backends that are coming and going. As we look forward into sort of a console-oriented world, we've begun to replace these IP addresses with the actual logical service names instead. So instead of asking for .51, you explicitly use DNS to ask for the auth service, and console dynamically figures out where that goes, and you're able to eliminate load balancers for this particular solution. And this is generally what people adopt console first for. We've seen multiple talks. There was one at HashiConf EU a few months ago and last year. We've seen multiple talks from our own users and customers that this is why they initially adopted console, and they're able to have considerable cost savings doing just this. There was a tweet just a few weeks ago about somebody who is totally cloud, full cloud, and just adopted this to eliminate application load balancers between services and was able to drop their networking costs by 90%. So this is sort of the bread and butter why you initially adopt the console. When we describe sort of the evolution of adoption maturity as crawl, walk, run, this is sort of the crawl step to get towards service mesh and some more complex solutions. After naming, once you have the ability to sort of name something, the next challenge that comes up is cool, you could address something, you could reach it. How do you control access to that thing? So the authorization problem comes up. And in a world where we're viewing everything as IP addresses, it makes perfect sense to use firewalls that operate on IP addresses as the mechanism to enforce this type of authorization. So using firewalls, you would do something like allow .51 to .104, and in that way protect access to your authorization services or whatever is back there. And again, in a more console-oriented world, as we look at things now through the naming aspect of logical service names, we are now operating authorizations, which we call intentions, through logical service names. So in the console world, you would say allow web to auth, the IP addresses sort of disappear, and authorization happens. And then finally, the last challenge is routing. And routing is really two aspects. It's the load balancing aspect of actually sending it to the correct instance, and then it's also the traffic shaping aspect, which is resolving it to sort of the right subset of the services you have running. So the load balancing is pretty simple. It's literally balancing load. And then the traffic shaping aspect is maybe you have V2 that you want to send 10% of traffic to, and so on. These are really important challenges to solve. And traditionally, again, these are done because we already have the load balancer with a load balancer, but it introduces quite a number of load balancers in the system and complexity as well. And with console, we're able to solve this sort of with our agent-based model, with a sidecar model, using the service mesh functionality in console. And so if we zoom out now with these three challenges and look at a traditional data center, it looked like this. There was a very clear north to south traffic path. You would have an external firewall, which is the big white box on the outside. Global internet traffic would come in the front door, which is a firewall. That would go to some front-end load balancer that distributed load to the web tier. They would do some processing, and then it would go back to sort of an internal back-end system like a database. And usually there was another firewall there. And these tended to be monolithic applications. They tended to be on VMs or in physical data centers, and they didn't move very often. They were fairly static. And so in this sort of environment, manually handling updates, manually updating firewall rules, using IP addresses is a perfectly reasonable thing to do. When there's not a lot of change happening, when there's not a lot of dynamicism, you don't need automation, right? But if we zoom out a bit more and we move forward into a more modern sort of deployment scenario, we start to see something like this, where you might have adopted a sort of a new data center or a new location, and because this is sort of a new thing, you've also decided to re-platform onto some new technologies such as Kubernetes. And all the while, you sort of still have this existing system. And maybe you intend to move things from the existing system to the new, but that's never an atomic, instantaneous event. So there's always this period of time where there's multiple technologies that exist. And because the existing system's sort of there, it's very common that you have to reach back either for user data or billing or identity or anything to sort of come back to the old data center. So you have to set up something like VPNs or SD-WAN or direct connects. There's some mechanism you need to connect these two things. In addition, sort of you have a different point of entry into the second data center. There's now 2 ways for the internet traffic to reach you. And so the notion of a perimeter is starting to disappear. And more and more, this is very complex. And this happens actually fairly quickly for a company. So like I said, even if you were a cloud-first company, if you existed sort of before the rise of containers or something, this is now a challenge for you, right? You have the cloud VM and the container challenge that you're trying to sort of bridge these gaps. Or if you're just a growing company and you're moving into multiple regions, this quickly becomes a challenge. And so let's zoom out one more time and sort of see sort of the end scale, the end state of high scale sort of complexity that comes about, and the importance of networking sort of in that environment. So in this scenario, it looks sort of like complete chaos, but this is really more the rule than the exception, is what I've found talking to sort of hundreds of companies in the Global 2000. And what ends up the way I want to describe how this happens is sort of with a story. It'll be an anonymized story, but true, based on the true facts. So let's imagine that you're a company that was actually cloud first. So let's keep it fairly modern. You didn't even have a physical data center, but you started cloud first about 8 years ago. You're cutting edge. You went all in on something like AWS. Let's say you just chose AWS as your cloud platform. And so for a long period of time, you invested heavily in tooling there. You have all your VMs there. Everything is homogeneous, and you're able to use sort of all the tools that AWS provides to have a very clean deployment. At some point in the past 8 years since that company gets incorporated, the rise of containers and container platforms starts to happen. But things like Kubernetes don't appear immediately, right? The first thing that happens are things like ECS or things like Docker Swarm or other sort of technologies come up. And so being the cutting edge company that you are, you quickly adopt these things, but you still have VMs and you're mixing them together. But it's still manageable, right? You have 2 systems. You continue growing as a company. Suddenly you have sort of global distribution, so you introduce new data centers. You're solving those challenges of having sort of multi-region capabilities. And then all at the same time, sort of Kubernetes is sort of standardizing the container platform like world. So you start adopting Kubernetes. Then function as a service, you can see sort of how this goes. So let's assume now after 8 years, you're a $1 billion company, you're doing very well. And as a business, at an executive level, at the business level, you decide that the best thing for this company is to acquire an adjacent startup company that's established, much smaller than you, but doing well. And so you go to acquire this company for business reasons, very good business reasons. But since they're newer, they've decided to go all in on Kubernetes on GCP. And so you bring this company into the fold, and suddenly you went from this very clean, pure AWS VM first, cutting edge company to now having sort of this as a very real reality. And that happened to a real company. That was a cloud first company. And so you could sort of imagine if you just stretch it to any other company that's been around more than 10 years, more than 20 years, that this is spanning clouds and spanning to their private data centers. It includes a lot more technologies. And so this is a very real challenge, and like I said, from what I've seen, is much more the rule than the exception. And so 2 years ago at HashiConf here in the US, we announced Console 1.0. And after announcing 1.0, we have been focused, the Console team has been focused on solving this broader service networking challenge. So release by release, we've been chipping away at this. And at HashiConf EU a few months ago, we announced Console 1.6, which had really the largest sort of user-facing changes towards solving these problems. It announced 2 major features that really took it to the next level towards solving the service networking challenge. And I want to just quickly review those. The first feature we released was something called mesh gateways. Mesh gateways are a solution that allows us to automatically have cross-network service mesh. So when you have 2 networks that are either multiple data centers or VM to container or just have completely overlapping IP addresses, you're able to automatically make these connections work. We do it in a way that maintains full end-to-end encryption because security is sort of an expected and necessary aspect of the network today. And our solution always spans sort of every available platform, so Kubernetes, VMs, physical, et cetera. You know, if you look at the way I described service networking and the way it works, it's such a core technology to bridging multiple paradigms that it's only a real solution if it solves a heterogeneity problem. If you look at a single platform and you solve service networking or service mesh for a single homogeneous platform, that's solving a problem, but it's not solving the problem that we're seeing businesses have. The problem is bridging together multiple heterogeneous systems, and that is what we are focused on solving. So if we look at this from a quick diagram point of view, here are 2 networks. The most common reason you have 2 networks with the exact same IP address space is generally Kubernetes. So you have 2 networks, you have an API service in one, you have a database in the other, and they want to talk to each other. Because they have overlapping IP space, you can't just set up a VPN, you have to do something a little more creative. It's possible, but challenging. With Consul, you just put a mesh gateway on the edge of each of your networks, and the connections just happen. And to the developer, to the API service that's requesting the database, it doesn't even need to be aware that the database is in another network or it could be data center or anything. The API just says, I want to talk to the database. Consul figures out how to do that routing, whether it's allowed, and so on. So this is really important because I don't think developers should really care what the topology of the underlying system is. This gives sort of the freedom of the operators and network engineers underneath to move applications and do what's best for their sort of deployment, and things still work at the application level. And if we look at just a slightly more zoomed out example, this is how it would work across container platform, cloud VMs, and physical data centers. You would just put a gateway on the edge of each of your network, and now all of them could connect, even though this is either over the global internet or over multiple regions, et cetera. And so that was one aspect of the service networking challenge, right? The way I like to break service networking into 2 different categories. There's the networking part, which is sort of how do you get the byte from point A to point B. Like the byte just has to get there. And then the security challenge is also part of that. You want the byte to get there encrypted, likely. Then there's the other aspect of service networking, which is the category of progressive delivery. This is a term James Governor came up with. But progressive delivery is sort of an umbrella that encapsulates features such as canary, feature flags, rolling deploys. And the business challenge it's solving is the idea that we need to somehow have a mechanism to limit risk when rolling out new software. And this is one aspect of limiting risk. You probably also want testing in different environments and CI/CD and so on. But bugs get to production. They always get to production. So how do we limit the blast radius of deploying these applications? And as we're now reaching the point where it's fairly mainstream for companies to have hundreds and thousands of microservices that are going out to production, how are you supposed to do this safely that doesn't bring everything down to its knees? And so the features underneath progressive delivery are the way you do that. And so with Consul, we also announced layer 7 functionality to do HTTP and gRPC routing, traffic splitting, and custom service resolution. And all of these solve the sort of the progressive delivery aspect of service networking. To show this in a diagram, this is what, prior to Consul 1.6, when you asked for the web service, this is what it looked like. Consul would just look up the web services and return them to you. In Consul 1.6, you can now introduce logic in between these, and all of them are optional, but this is what the full chain would look like. You could do routing, traffic splitting, and resolution. And so to run through a quick example of what this does, sort of at step 1, we could do routing to say, if we ask for the web service but the /admin path, that goes to the admin service. If And then when we're in the admin service, we want to split 10% of the traffic towards V2 and 90% towards V1. So we split towards V2. And then finally, the resolution step actually informs Consul, how do I resolve the V2 admin service to an actual instance? And so there we're able to say, well, all the services named admin that have a metadata of version equal to 2 are that service. And so finally, the green boxes are what Consul determines are what you want to talk to, and it returns those all the way out. So you can see how this sort of functionality lets you do this progressive delivery. And so all of this is in Consul 1.6. We announced that at EU. It reached stability in a final release about a month ago. And so this is all out already. But we could see from this sort of the importance that networking plays in this sort of multi-everything adoption, multi-platform adoption, and sort of the critical functionality that Consul provides. And so it's very important that Consul is as easy to adopt as possible. The Consul core team has been doing really good work every single release to make that easier. If you look back at the past few releases, we've made securing by default easier. We've made introducing ACLs easier. We've made upgrades a little bit easier. There's been, little by little, we've made things easier. But we always wanted to do more. And so we went to the drawing boards, like, what can we do to make Consul easier to adopt? And an obvious answer stood out, which is we could run it for you. And so today, I'm excited to announce the HashiCorp Consul service on Azure. So HCS on Azure is the easiest way to launch and integrate service discovery and service mesh. It is Consul as a service, and it is also the first fully managed service mesh as a service. The features, as a service, you get the features you would expect. We provision Consul clusters for you automatically. We handle backup and restore. We handle upgrades. We handle scale up and scale down. And all of this is consumption-based pricing, time-based pricing. It's not a big upfront commitment. By integrating very deeply with Azure, we're able to keep Azure native identity and billing. So with this release, you actually are able to, you don't need to sign up with us. You could use an Azure identity, and our costs show up on your first-class Azure bill and are billed directly through however you pay Azure. But all of this is HashiCorp managed. So when you create a Consul cluster, when a backup is necessary, when we perform an upgrade, all of that control plane work is handled through software that's built and run by us. It runs in our data centers, or cloud data centers. The software is written by our engineers, et cetera. We've hired and built out a HashiCorp SRE team that is handling the management of all the customer clusters. But all the while, we've partnered with Microsoft to sort of deeply integrate across from sales to technical implementation. As a quick diagram of how this works, but we'll run through a demo, but a quick visual diagram starting in the middle and then going right and then left. So you would find the HCS sort of application. You would ask us to create it. That comes back to our software, and we handle the creation. And the creation of the cluster actually shows up in your account in a managed group. We have access to modify the resources just in that group, but by putting it into your account, you could easily do VNet peering or handle any way to sort of get access to those Consul clusters. It's way easier to see with a demo, so I'm going to just show you a recorded video of what this looks like. So what we're going to start with here is the page you would see after hitting Create Consul Cluster. And you'll notice this is just right in the Azure portal. It feels just sort of like a first-class system directly in Azure. And so this is the first thing you see. So I'm going to start the video here. One of the first things we'll show you is selecting the region. We are supporting right away at launch every single Azure region that they support, every single public Azure region. You would select your resource group that you want to launch this in. You could create a new one, which is what we're going to do here, empty resource group to launch all the Consul resources into. And then after this, you hit Next, and you're presented with a bunch of Consul settings. So you could name your cluster, name the logical data center, choose the Consul version you want to deploy, determine your backup and upgrade behavior. Do you want automatic upgrades? Do you want manual upgrades? What interval do you want us to take snapshots in? There's a number of options here that you could choose. So you go ahead and choose them, hit Next. We validate the configuration for you, and then once it's valid, you could hit Create. That initiates a deployment, which we'll click into here. The deployment takes a few minutes. We fast forward it in the video. But the deployment takes a few minutes. Pretty soon, you'll see an HCS instance show up right here. And then very shortly after that, that'll become clickable. When you click into that HCS instance, you land on an HCS on Azure dedicated page. And you'll see in the sidebar a bunch of console-specific things. So the first one we look at is the console clusters list. This lists all the clusters you have. You could add more. You could see metadata about it, the version, so on. And if you select the cluster, you could do a bunch of manual steps, such as manually forcing a snapshot or manually performing an upgrade. And then in the left-hand side, you'll see a link to the UI as well. So we click that here. And when you click the UI, it loads the console UI directly in the Azure portal. This is a lot fancier than it looks, actually, because what we're doing here is when we deploy a console cluster, we deploy everything secured by default. TLS is fully set up, ACLs are fully set up, gossip encryption is all there. So when you load this UI, you'll notice that there's sort of no token entry required or anything. Since we integrate deeply with Azure, when you clicked that button, we were actually able to use your Azure identity to prove that you have access to the console UI and log you right in. And so you get access directly there. You could also choose optionally to put the UI on an external endpoint if you want to handle access yourself, or you could keep it private and only access it through the Azure portal. And so this shows you sort of the quick example of HCS on Azure. Like I said, we've partnered very deeply with Microsoft. We're excited by that. And to talk more about Microsoft and Consul, I want to invite to the stage Brendan Burns, a distinguished engineer at Microsoft.
Great, thank you. Thanks, Mitchell. It's been really great to develop this partnership with HashiCorp and see the benefits that the combined forces of Hashi and Azure can bring to our joint customers. Because the truth is that when you're building applications in the real world, it's a really complicated hybrid environment. You need the ability to interact with both existing services that may be running on VM-based infrastructure, with newer microservices that might be running in Kubernetes, in the Azure Kubernetes service. You need to be able to have all of this stuff work on-premise as well as in the cloud across a wide variety of environments. So most applications that we see out there aren't the pretty diagrams that you see in the cloud-native application portfolio, but rather a complex collection of pipes going in different directions. And the combination of Azure's technology and Consul can make a really great way to bring those applications together. To give a demonstration of this, I'm going to go through our legacy application that we're using Consul and Azure to help modernize, and that is Cloud Pong. So Cloud Pong has been a successful legacy application. Well, it started out as a new application, but it became a legacy application based on virtual machines, hard-coded IP addresses between the different players. Pretty happy with it, but our agility isn't just where it needs to be. And so we're going to microservicify that thing. We've gotten, if you've seen the recent Dilbert cartoon, we had the pointy-haired boss come in and say Kubernetes to us. So we're Kubernetes-ifying our service. But as we do that, the question becomes, we've got these services over here. Kubernetes is cloud native, and that's wonderful. But we still have this VM based for our second player, and we have to do this migration successfully. How can we make sure that we bridge the world of dynamic services in Kubernetes with a more legacy world of virtual machines? And it turns out that to do that, Consul is a great solution. Right? So Consul is something that we see with our customers a lot, specifically around this notion of bridging from a mesh that's in Kubernetes and a mesh that is in other environments. But the question is, how do I drive this? How do I make this work in a Kubernetes-centric way? And how do I ensure that, if I want to use other service mesh implementations, because at this point, every couple of weeks, there's a new service mesh being announced, how do I make sure that it all works and that I'm learning and my tools can use the same thing? And so to do that, a while ago at KubeCon in Barcelona, we partnered with HashiCorp and others to come up with this service mesh interface specification. It's an open specification. It's out there on GitHub. And you can use this open specification to drive your service mesh so that you're not bound to any particular implementation. You can use Consul if that works great in the managed service on Azure. If you're in a different environment with a different implementation of service mesh, you can use the exact same Kubernetes objects to configure and set up your application. So to give an example of this in the real world, I've actually deployed exactly this architecture out onto Azure using Consul, using the Azure Kubernetes service, using a legacy VM. And I want to give a demo of this. So in order to do that, we're going to have a demo of Cloud Pong. But of course, you really can't play Pong without another player. So to do that, I understand we have a volunteer from the audience who's going to come up here, and we'll do a little Pong on stage for you. So this is the step to any successful startup. Grab our volunteer. Something magic will happen, and hopefully we'll profit out the other side. So come on up. All right. Thank you. Thank you so much. All right. Let's get this set up here. We're going to keep our fingers crossed. Oh, is my screen? Is my screen on there? I can't actually. Oh, my screen is there. Awesome. Cool. All right. So I'm going to set up my my game here. Many thanks, by the way, to the folks who helped me build this. And over here, we're going to set up player 2 for you. Sorry, I'm going to type a little bit for you. But it looks like player 2 is not connecting. We're not actually seeing player 2's, the paddles or the ball on player 2's screen. So she's going to be at a disadvantage. I'm going to win. No, I'm kidding. And it turns out the reason for this is because console, as Mitchell mentioned, is secure by default. And if I go over to the console UI here, what you're going to see, if I hit refresh, oh, is that, this is my, I'm just going to show you that this works, even though I didn't reset my demo. Does that mean I win? You win. No, so I'm going to show you how the SMI is able to control console. So what you see here is none of the intentions are there, which is not allowing the connections through console from player 1 to player 2. We can actually use the service mesh interface here to create those intentions. So if I actually take a look at the policy, these are Kubernetes objects. I can actually show you the policy. So these are actually Kubernetes objects that control the connections between the services that are exposed in Kubernetes and the services that are exposed on the VM. If I go ahead and create those, that says delete. They're not there. Deleting doesn't work. I'm going to create the createe. See, live demo. All right, so now we've actually created those. We'll go back over to console. We're going to hit refresh. And the intentions are there. So now if I go back to my Pong, all right, and we'll go back to your Pong, and we will try and reconnect, and we are ready. All right, you ready? So it's arrow keys up and down.
Okay.
Space bar if you want to hit the ball. Although it's my serve. So,
okay.
All right, you ready to go?
Yep.
All right, here we go. It's thrilling. We needed a play-by-play. I should have a play-by-play announcer. Is it not? Hold it. Try holding it down.
This is rigged.
It's rigged? No. Oh, maybe is the menu? Oh, see, there we go. All right. Well, where's your mouse? I'm gonna make sure your terminal's selected here. It's max. All right. Let's see if the spacebar works. Spacebar. Man. We'll try this again. I want to give you a fair shot at this, after all.
I appreciate that.
Really. All right, let's try it now. No? All right. Well, I'm gonna have to apologize. I don't think. Yeah, I really didn't intend for me to be the only one with controls that worked. But yeah, I guess that's the situation we find ourselves in. So you have to at least, at least I can make my controls work. All right, well, thank you so much.
You're very
I
welcome.
really apologize.
Great game.
Thank you. Yes. All right. Thank you so much, and we're going to have Mitchell come back onto the stage and tell you more. Thanks. Oh, clicker. There you
Thanks.
go. Thank you.
All right. Well, that demonstrates the importance of progressive delivery, I think. Yeah, OK. So Brandon showed a good example of sort of how you could use console and integrate console in a Kubernetes and Cloud VM world. This is a super common deployment today. But I also showed earlier, in addition to that, the addition of private data centers. And many private data centers are out there running VMware technologies. And so we want to make it as simple as possible for console to enable service mesh across all of these environments. And so to help talk about this next step of going to private data centers with VMware, I'd like to invite onto the stage Per Monklis, who is the CTO of Networking and Security BU at VMware.
We saw this morning a discussion with Armon that everything was going multi-cloud, multi-application, multi-service. At the same time, we were seeing from Mitchell the idea that networking is much more than IP address and connectivity of switches and routers, but it's evolving towards providing what we call service communications. And within this new world, what we are seeing is that customers are coming to the industry and essentially demanding, how do I connect these environments across multiple silos? So today, from every time I deploy a Kubernetes environment, every time I create a cloud-native app, every time I go to a public cloud, essentially I have a microcosmos of operational models, security models, identity models, connectivity models. And what happens is it's very difficult to eventually operate the whole thing as a cohesive system. So we started working within a group of companies, and we started realizing that we couldn't repeat some of the patterns of the past, of the notion of saying, we have an environment in private cloud, in public cloud, in Kubernetes, and they are kind of isolated, managed by different teams. So we started discussing about this notion of how do we understand what a service is across heterogeneous environments? How do we connect a microservice in one side to, let's say, a VM on the other side? And it was going back to the fundamentals of what connectivity is. This is kind of the evolution as we go to the service networking that we were discussing with Mitchell. This notion that it's not anymore about connecting from IPA to IPB, but rather how to understand identity across environments. How do we understand end-to-end connectivity? How do we understand policy? How do we understand service discovery? So for that, we started working and defining in an open standard with open source with a group of companies how to essentially exchange information between two disparate meshes in a way that from an operations and visibility point of view, they could work together. There is a session today in the afternoon that basically we go into the details of how Consul Connect federates with a service mesh project that we have at VMware and a SEC service mesh, and how you see an end-to-end connectivity on those. That's an open framework that we are working within the community. There's participants like Google and other players, and essentially allows you to stretch the notion of this service networking, this service mesh, across multiple environments. Now, provided that we do that, then we achieve essentially this end-to-end, what we call enterprise class service mesh. The idea is the fact that now we can essentially discover, monitor, control, have consistent policies across all the environments that you may have from a service point of view. Now, within that though, when we were talking to our customers, we were seeing that this was potentially not enough. I mean, if you think we are very focused on how a service interoperates with another service. But as we go to these layers of communication, essentially, as we move from traditional networking to how microservices communicate, the picture is much more complicated because now as we get inside the semantics of the application, what we have is that services are there to provide some useful value to the users that connect to those services, the authentication aspect of what user connect to what service. And eventually we end up writing to a data object. So now within this evolution of networking, service networking and communications, what we are building at VMware is essentially expanding the meaning of what you connect, which in this case was a service, to something much more broad, like how a user connects to a service and how this service on behalf of that user writes into a data store. That allows us to essentially have what we were discussing before about spreading this mesh across multiple compute environments, multiple clouds, but at the same time extend it to these three principles in a way that when we discover what services do we have, we by definition discover what users authenticate to those services and what data objects are being written. In a way that then when you have the visibility of understanding what's the SLO that you observe from a microservice, you could say what's the experience that the user is seeing from that entity. And as you go to the control, you could start thinking in terms of why are users in Europe writing into objects in the US? Is this a GDPR violation? So as you see, the notion of going to the service networking or the service mesh concept, it's a fundamental transformation because now it brings capabilities that before were like hidden in multiple layers of the infrastructure. Now you can get closer to the business policies of what you intend to do and use the deeper semantics that service networking has into the application to provide that. Now, of course, and it was discussed before, this is not just about how to create connectivity across cloud native or connectivity across multiple Kubernetes clusters, but is how do I extend whatever service mesh concept I may have in the cloud native wall, how do I extend it into the virtual machine wall? How do I extend it into the physical mainframes and bare metals? To that extent, we are, of course, integrating with different components of the VMware family and different partners outside on how to make sure that we can communicate the current service networking of the cloud native wall to the previous one that Mitchell was discussing about load balancers and IP connectivity. So just to summarize, we are very excited that to be part of this collaboration with HashiCorp, because essentially in this multi-cloud, multi-service transition that we are going, the only way that we are going to satisfy the requirements of an end-to-end security model, an end-to-end connectivity model, if we start working and collaborating more in these frameworks about how to federate environments to solve end-to-end problems. Thank you.
Thank you, Per. All right, thank you very much, Pere. And so that is everything about Consul. So HCS on Azure is available in private beta today. If you'd like to get access to it, please get in touch with us. And you can look at hashicorp.com/HCS to learn more. If you want to learn more, I only talked about the high level. Directly in this room right after this, we have Brandon Chavez and Alex Dadgar, both members of the HCS team, who are giving a talk. The title is this, but it's actually an HCS talk. So they're going to go through everything from running, the high level of why into more of a technical deep dive of how it works and how you integrate it into your environment. So stick around if you're interested in that. And then for other products later today, I'm going to highlight a couple, but we have more than this. Nico will be talking about building Vault plugins, which is a really powerful thing to do. So he'll be talking about that at around noon. And then Danny will be talking about managing stateful workloads on Nomad, which is always a fun thing to do with schedulers. So please check those out. They're both going to be excellent talks. And now to help close us out, I'm going to introduce to the stage our CEO, David McJanet.
Thanks. Thank you. So obviously we made a bunch of pretty significant announcements today around Terraform and Consul. And I wanted to maybe just step back a minute and provide a bit of context to what it is we're trying to do as an organization. I think, as Armand highlighted, whether by accident or by design, we live in a multi-infrastructure world. And our mission is to enable consistency around how you interact with those core principles of that modern infrastructure stack. So I think if you think about what we've done actually collectively over the world of infrastructure provisioning over the last couple of years, it's actually kind of astounding to see the progress that Terraform has made. And honestly, we do some of it, but many of you in the room do much of the rest of it, where today not only is Terraform sort of in some sense a standard way for interfacing to how you provision infrastructure on Amazon or Azure or Google or even Alibaba or vSphere. The inventory of providers outside of those cloud providers is actually kind of amazing. I think there are 250 plus distinct providers in the Terraform ecosystem. And all you need to do is spend a couple of seconds on the GitHub repo to see the velocity of how those are evolving. I usually actually in some of our customer meetings, I open up a browser and say, listen, I think if you want to see what a vibrant community looks like, just spend 30 seconds refreshing your browser in the GitHub repo for the Terraform providers. Literally every 10 seconds, something new is being updated and it's being done by you. What that allows is for you not just to configure the infrastructure on Amazon or on Azure in a consistent way, but you can now configure the dependencies associated with your infrastructure stack because Terraform's templating mechanism allows you that single language for really everything that you need to provision. That's super cool for us to see, and we're super grateful for the work that the community does. The second principle, as Armand talked about, is in the world of identity-based security. I think the notion of identity as the basis for who can access what and what machines can access what inside the data center is a pretty profoundly clear thing that we've all understood in the world of sort of users accessing machines, and whether it's Okta or the like for the user use case. For the machine use case, I think this general sort of harmonization around the identity-based model for machines is one that really has taken hold, and many of the most sophisticated applications on the planet use Vault to underpin this process. And the model's super cool for us because what you see is given the modular nature of it, much like Terraform, really on the left-hand side, any authentication mechanism that you're interested in, whether it's LDAP or Active Directory or Azure Active Directory, can be loaded as a backend. And then you can really connect literally any system that you like. Again, if you watch the repo of system backends on GitHub for Vault, you'll see that literally any system you want to apply this principle to is available to you. And that only happens by virtue of having an enormous community of people collaborating in the open source to make this happen. The next bit, and you've seen, if you've been focusing on what we've been really announcing, and it's not just Mitchell that's been talking about this, although he's been the face of the last couple of conferences, this notion of networking is a profoundly difficult thing in the cloud model. I think those of us that have been looking at this for a while, you sort of stare at it and go, hold on a second. In the cloud model, the application elements are coming to us in much smaller pieces, largely in the form of containers. Number two, they're ephemeral by design, which means they're going to scale up and scale down. That means they have different IP addresses every time they come and go. So it's, in a sense, implausible for a human to reason over the firewall rules associated with those applications. That's why for most of our customers, actually the networking challenge is the biggest challenge for applications actually seeing traffic after they're deployed, just because of the firewall realities of that. It sort of stands to reason the same way we went to identity as the basis for security in the machine sense. You sort of have to inevitably go to service name as the basis for routing in the networking sense. The service mesh use case is sort of a derivative of that, but step one, and the reason that Consul is by far our most widely deployed product as a company, not always that well known, is because you kind of need to create this common registry that tells you where everything is. When I deploy a new application into that world, it updates the registry, and then I can do derivative things from that. Now route from service A to service B. And then the more extreme use case that there's a lot of light and heat around, the service mesh use case, is about now enforced encryption when those things actually speak. But the higher level construct of service networking to us just feels, in a sense, inevitable, and that's why we spend so much time and energy on this, and it's why Consul is an enormous investment for us, and it's super fun for us to see it get used. Because I think what we all in this room recognize is that the shift to cloud is not just a shift in dropping an artifact somewhere new, it's actually a completely different way of building and delivering applications, because what you're now doing is you're dropping that application or artifact into a low-trust network that has no clear network perimeter, that is ephemeral by design, and that causes all the participants in the IT chain to have to rethink how they do their job, which is why Armin described it in the layer view that we did earlier. We have the benefit of speaking with literally hundreds of companies around the world on a weekly basis, and I think the pattern that we see most often is actually played back to us. This is not something we prescribed initially, but this is what we observed maybe a year and a half ago. People are standing up Terraform as a central shared service for their organization, and then they're telling their application teams, if you want to go to cloud, I'm giving you one aperture. Nobody else gets the credentials to Amazon or Azure. I'm going to control it through a single set of templates that are pre-approved. If you use Terraform and the central shared service to Terraform as the basis for those applications getting deployed, you can deploy 100 times a day. Knock yourself out. At the security layer, again, we see people building the central shared service around Vault to use this identity-based notion, first of all, to enforce access to system secrets, but ultimately to enable encryption and advanced data protection use cases around those applications in the cloud model. And they say, if you reach back to Vault for your credentials, you can deploy your app 100 times a day, right? I'm getting out of your way. I'm sort of giving you my implicit sign-off for you to deliver that application to that cloud world. At the networking layer, again, if they say, hey, if you want that application artifact to see traffic when it gets there, we need to have a sign-off previously that says you're going to include Consul client in that application element when it goes. I will run a central shared service for Consul server so that then when that element lands in the cloud model, whether it's on-prem or whether it's Azure, I will route traffic to it straight away because I will discover it. And now I will actually optionally encrypt it, and with the service on Azure, it gets even easier because now that can be set up for you, but that model just makes a ton of sense. So whether it's a Java app, a .NET app, a Cloud Foundry app, a Kubernetes app, a Nomad scheduled app, it doesn't really matter. So when we talk about the cloud model, this is sort of what we refer to, because the consistency that we get to see as a vendor is on how all of our customers end up deploying our products, and this is what it looks like. The other really cool thing for us is that you all are at the center of this. You're the ones that are sharing with your organizations the realities of what it means to deliver applications in the cloud world. You're the ones that are providing this critical enabling role. Our role and our commitment to you is to continue to deliver these tools using the open source model. We think this is the way we can aggregate enormous communities together to make this all work for all of us. Number two, our commitment is to build commercial versions of these projects because we recognize that an individual's technical need to provision 100,000 machines on Azure is different from the challenge of a team or an organization that has to work with that tech. It's kind of like going from Git to GitHub in a sense, right? The team problem is one of collaboration. The organization problem is one of governance and policy associated with that provisioning process. That is something that our customers have brought to us as a requirement, and that is where we build our commercial products. The third element that we're committed to is to continue to invest in the organization to deliver on the trust that you implicitly place in us when we play that role. When you commercially partner with us, it allows us to invest back in the ecosystem, build better documentation, build our products, partner with bigger organizations to allow you to do what it is you do, and that is build mission-critical applications every day. Obviously, we couldn't do this by ourselves. We have an enormous ecosystem of partners that we work with. I think it's particularly cool that we have Amazon, Google, Azure, and VMware as platinum sponsors at this event, which I think is indicative of the role that our products enable for those companies and essentially reduce the friction to the consumption of those platform technologies for all of us. But obviously beyond that, there's an enormous ecosystem of people that I would highly encourage you to take a look at downstairs in the partner pavilion in particular. If you're running cloud infrastructure, I'm almost certain that these companies are of interest to you. And obviously we have an enormous ecosystem behind this. Maybe just in closing, I kind of want to step back even further, and I think our central view is that the infrastructure that we provide enables some of the most sophisticated applications on the planet to be built. Right? That is a super fun role for us to play. We take it incredibly seriously, but you're the ones driving the change. We're here to help you, and I just want to take a moment to say thank you for all the support that you give us. This is a really, really fun thing for us to do, to see when we talked to customers yesterday, just as an example, you get to see how significant these products are in the runtime of some of the most important applications on the planet. So